Yes. So I think the chemical formulas totally we did. I mean the chemical formulas, that relative formula mass, we completely discussed, right? Okay. What? Characteristics of organisms. Yeah. We did that. My goodness. We did all the chapters until 12th except the 7th and the 10th one, because I told you both the chapters are chemistry we are doing at once. So now we are doing at 7th, inshallah, we are finishing up today. 10th will be starting next week. Next week, 10th we are starting, and next week we are having a seminar. At the end of the class, I'll speak about that. So next week, 20th, we are having a seminar, inshallah. Sunday. Sunday, yeah. Next week, Sunday, we are having a seminar. Actually, two seminars we have. One is for BS, the other one is for science. BS and science. I spoke about that last month, actually. I told you that we are having a seminar, combined seminar. 20th, it falls on. I'll speak about that at the end of the class, right? We come to the point. Avogadro's constant. What constant? Avogadro's constant. So, guys, earlier we spoke about atomic mass unit, mass relative to whom the masses of other atoms and molecules are found. We learned AMU, and what is the AMU we are using today? 1/12th of carbon 612 isotope. 1/12th of carbon 612 isotope, right? And second one, relative atomic mass, relative molecular mass, the third one. Relative to AMU, isn't it? Relative to AMU, atomic mass unit, what is the mass of an atom? What is the mass of an atom of an element relative to atomic mass unit? It is what we term as RAM, relative atomic mass. Relative. Relative molecular mass means what is the mass of a molecule? What's the mass of a molecule relative to the mass of other, relative to the mass of atomic mass unit, AMU. Okay. What is the mass of a molecule relative to AMU? That is called relative molecular mass. So RMM, how do we find? Real mass dividing by AMU, atomic mass. Okay. And then we came up with RFM, a set of workings we did. Relative formula mass, basically it is found for ionic compounds, but I gave as a mixture of many compounds, ionic equivalent, all of them were there actually for you to practice, right? How do we find it out? Sum of the total of relative atomic masses we did. Total of relative atomic masses we take, that is equal to relative formula mass. Relative formula mass. Okay, fine. So now we're gonna take Avogadro's constant. 4 more topics are there we have to speak today. What is this Avogadro's constant? Avogadro's constant. Avogadro's constant says that one mole of any substance. The new words are there, right? Now what I'm going to do, the rest of the 4 topics at once I'm going to take. Okay, that's easy. 1 mole of any substance. Now what is this 1 mole? MOLE, a new word for you. Right? 1 mole means we learned relative atomic mass, relative molecular mass, right? Right? Relative atomic mass, that is the mass of an atom relative to AMU. So this mass I'm going to take in grams. Why do I say take in grams? Because relative, when we learn, we didn't give a unit, right? Relative atomic mass, relative molecular mass, relative formula mass, we didn't give a unit, no grams, because it's cutting off, cancelling it. But here, that value, let's say the value is 10, I'm taking that 10 in grams. If the relative atomic mass of an atom we take in grams, relative atomic mass of an atom we take in grams, right? It says that this relative atomic mass taken in grams contain 1 mole. So, relative atomic mass in grams. And this is taken for an atom of element. It contains 1 mole. Same way, relative molecular mass we take in grams. And this is taken for whom? Molecules of elements or compounds. elements of compounds we take. And if this is taken in grams, also we say it contains 1 mole. 1 mole. Example. That means, now if you want to be very clear, we have to build up. Let's say I'm going to take 1 gram of hydrogen. 1 gram of more hydrogen. Hydrogen is 1 gram, right? Hydrogen relative atomic mass is 1. So I'm taking in grams. 1 gram of hydrogen. 12 grams of carbon. 16 grams of oxygen. All atomic level, okay? 14 grams of nitrogen. 23 grams of sodium. 24 grams of magnesium. 27 grams of aluminium. And 35.5 grams of chlorine. 40 grams of calcium. All these are relative atomic masses taken in grams, right? Okay. This says that it is equal to 1 mole. So 12 grams of carbon you take, it is equal to 1 mole of carbon. 1 gram of hydrogen you take, it is equal to 1 mole of hydrogen. Huh? Somehow 1 mole, which is equal to that particular atom's atomic mass. Okay, atomic mass. So 16 grams of oxygen is equal to 1 mole of oxygen. 14 grams of nitrogen is equal to 1 mole of nitrogen, not others, nitrogen. If it is potassium, 39 grams. Calcium, 40 grams. 40 grams of calcium is equal to 1 mole of calcium. You got it? Is that clear? So whatever the relative atomic masses we take of an element, that relative atomic mass is equal to, okay, that relative atomic mass is equal to 1 mole of that particular atom. Okay, all 20 that we are learning and 100 plus elements are there. Those are having their own atomic mass, right? Relative atomic mass, right? That relative atomic mass amount you take in grams, it is called 1 mole of that particular atom. Clear the point? Clear? So, in that relative atomic table, whatever the atomic masses are given, you have the relative atomic mass of all 20 elements, right? They are the grams for 1 mole. And this is furthermore known as grams of 1 mole. How many grams are there in 1 mole? Correct? So, 1 gram of hydrogen contains 1 mole means, what is the mass of 1 mole of hydrogen? 1 gram. 12 grams of carbon is equal to 1 mole means, 1 mole of carbon contains how many grams? 12 grams. 23 grams of sodium. 23 grams of sodium contains 1 mole of sodium means 1 mole of sodium, what is the mass? 23. Did you understand that? Okay, okay, right? So 24 grams of magnesium is equal to 1 mole of magnesium means you take 1 mole of magnesium should be equal to 24 grams in mass. Clear? Right. So this is called 1 mole. It is called 1 mole. And this 1 mole's mass we term as molar mass. What mass? Molar mass. Molar mass. Mass of 1 mole. Mass of 1 mole. Right? Molar mass. And Avogadro, how it is connected? 1 mole of any substance you take. 1 mole of any substance you take. Now look at the point. Look at the point. Relative atomic mass taken in grams is equal to 1 mole. And in this 1 mole, you put some grams by spoon, let's say. For example, you are taking some salt. Taking a spoon. You are going to apply. And the grams you measure. Now in this container of salt, how many salt particles are there? Go home, take a spoonful of sugar or salt and count how many are there. Can you do that? You can, but it's hard. One by one, you have to take, right? Okay? So at least they have. Actual thing is, they are not the molecules you are separating it, okay? They are some particles. That particles only you can count. You can't count the molecules by your naked eye. Molecules are even smaller than that. Okay? They are ground up, okay? Grinding, after grinding, whatever the particles you do have, that is what you can see. Molecules are even smaller than atoms, are even smaller than that number of times. Right? At least those particles, it's hard for us to count, right? So you see, in that grams, how many particles are there? This particle number is constant. This particle number is constant. This constant number is termed as Avogadro's constant. And how much is this Avogadro's constant? It says that 6.022 into 10 to the power 23 atoms are there. How many atoms are there? 6.022 into 10 to the power 23 atoms are there. That means you take, right, 1 gram of hydrogen. You take 1 gram of hydrogen. This has 6.022 into 10 to the power 23 hydrogen atoms. How many hydrogen atoms? 6.022 into 10 to the power 23 hydrogen atoms are there in 1 gram of hydrogen. You take 12 grams of carbon. 12 grams of carbon is 1 mole of carbon, right? 12 grams of carbon is 1 mole of carbon. So 1 mole of any substance contains 6.022 into 10 to the power 23 particles, right? So 12 grams of carbon contain same amount of carbon atoms. 16 grams of oxygen contains the same number of oxygen atoms. 14 grams of nitrogen contains same amount of nitrogen atoms. Understand? And 40 grams of calcium you take, it contains 6.022 into 10 to the power 23 same amount of calcium atoms. Okay. Then why the hell the masses are different? You may ask me, if the amount is same, how come the mass is different? You take small Jill bowl, you say glass bowls. 1000 you put in a vehicle. 1000. Number is 1000. But the mass will be different, right? Yeah. You take plastic balls. 1000 you put in a vehicle. 1000. Number is 1000. Will be the same mass. Metal balls, 1000. Bumping balls, jumping balls, different balls are there. Tennis balls, volleyballs, whatever the all 1000 would be the same. It won't be same. It won't be the same. It's different. So you see, 1000 number is same. But depending on the size, okay, and the volume it occupies, the mass is different. That's the idea. So ultimately, this amount of hydrogen atoms you take, that is equal to 1 mole of hydrogen. That is the relative atomic mass of hydrogen. Okay, the grams. So 12 grams of carbon you take, that is 1 mole of carbon. That is the relative atomic mass of carbon, 12 grams. 1 mole of carbon containing 6.022 into 10 to the power 23 carbon atoms. 27 grams of aluminium you take, it contains 1 mole of aluminium, 6.022 into 10 to the power 23 aluminium atoms. Did you understand that theory? Is that theory clear? Okay. So atomic sizes are different, so their masses are different. Sizes, their densities are different, so the masses are different. But number is constant. Now let's say, definitely you know 1 mole contains this amount means how much would be 2 moles containing? Double of that, right? How much would be 3 moles of substance contains? Triple of them. 10 mole of them, 10 times of them. You understand that? Clear the mind? That's it. This is the idea you have to get properly. This is the point where the students mistake with the entire lesson go off. Okay, this is the idea. If you understood this, you have to apply that into calculation. That's okay. Okay. You have to apply this knowledge into calculations using the forms, using the formulas. That's it. Right? So you see, this is about the atoms, right? Atoms in elements. Now, what if I take the molecules? Look at this. Same thing. We wrote the relative formula masses, right? Tell me how much is water. Can you remember it is 18 grams of H2O. Okay? H2O 18 grams.
Oxygen 16, hydrogen.
Yeah, hydrogen 2.
Yes.
2 in 1 plus 16. 18, right?
Yes.
18. And then we take H2. Now it is H, right? Hydrogen. I'm taking 2 grams of H2. H2 is a molecule, right? Hydrogen is the atom. But how do we get hydrogen in the atmosphere? As hydrogen gas. H2 gas. H2 is a molecule. 1 plus 1, 2 grams. So 2 grams of hydrogen gas, okay, it is a relative molecular mass of hydrogen gas. hydrogen atom, just H atomic mass. Just H atomic mass. Only one hydrogen atomic mass. Two of them are there combined, it is H2 gas. In this way only H2 gas is there. H2, H2, H2. Right? So this H2 is 2 grams. 2 grams. And it is relative molecular mass. Relative molecular mass. So same way oxygen. It is 32. Because one oxygen is 16, O2 is 10. Nitrogen 14. But it is existing as N2 gas. So N2, so it's 28. Got it? So now let me take glucose. Glucose and UTA, 180 grams are there. We all know these, right? C6H12O6, we found it as 180 grams. Sodium chloride UTA, 58.5 grams of sodium chloride. Calcium carbonate, 100 grams of calcium carbonate. All these are molecules, right? All these are molecules. Give me some examples. CH4, methane, 16, right? 16 grams of CH4, methane. Potassium carbonate, how much? K2CO3. Check how much it is. 157.9. Okay, can I write that? K2CO3, 100. 157.9 grams of K2CO3. So this is the total mass they have, right? In one. So this is called 1 mole of the compound. 1 mole of the compound. Element of compound. Potassium permanganate. Let me take any answers. Any simple ones. NH3, 17 grams. NH3, ammonia. Easy. Right? Now you see, all of them are supposed to be 1 mole. 1 mole. 1 mole of compound, element of compounds, because these are elements, right? Elements in the form of molecules, right? And also contain 6.022 into 10 to the power 23. Now we don't say atoms. We don't say atoms. What we say? Molecules. Why? Hydrogen has single atom. Hydrogen gas, it's having 2 atoms. So I can't say atoms. It is a molecule. It is a molecule. Oxygen is 1. Oxygen gas is 2. Nitrogen is 1. Nitrogen gas is 2. Right? So you see, it has to be molecules. Did you understand that? Do you understand that? So elements contain atoms, compounds contain molecules. Molecules. So you see, both of them are having the same number. So 1 mole of an element contains grams equal to relative atomic mass. 1 mole of a compound contains grams equal to relative molecular mass. So this 1 mole contains 6.022 into 10 to the power 23 particles, we say. Particles. Okay, particles. How do you take the particles now? Atoms in element, molecules in compound. Elements and compound both you can take because of these people. Okay. So if it is combined, we take it as a molecule, right? So atoms or molecules, atoms, the particles refer to atoms, molecules, or ions. All three we take. But we basically speak about this atoms and molecules. Atoms and molecules we are speaking about. Did you understand this? Clear? So now you see this 1 mole containing 6.022 into the power 23 particles, right? Okay. This is what we term as what constant? Avogadro's constant. What is the constant here? Avogadro's constant. Not avocado. Avogadro. Avogadro's constant. It is a constant value, fixed value. Okay, fixed value. Whenever you look at avocado, remember Avogadro, what he said. Okay, Avogadro. Right. So that is containing 6.02 into 10 to the power 23 particles. Now, right? Now, furthermore, I told you this relative atomic mass, no units. Relative molecular mass, no units. Same mass will take for 1 mole. Same mass will take for 1 mole. The mass of 1 mole is called molar mass. What mass? Molar mass. And this molar mass is given the unit GMOL minus 1. GMOL minus 1. How do you read? Grams per mole. Why? Molar mass means mass of 1 mole. Grams of 1 mole, grams per mole. GMOL minus 1. And remember, same number comes, but without units, with units. Relative atomic mass of hydrogen is 1. Relative atomic mass is 1. No unit. No grams. Relative atomic mass, what we found earlier, we didn't give any units, right? Relative atomic mass of hydrogen is 1. Relative molecular mass of hydrogen gas is 2. Relative. No units. For them, no units. Okay? For relative atomic mass, relative molecular mass, no units. But the same number you give it with the word of molar mass. Molar mass of hydrogen is 1 gram per mole. Molar mass of hydrogen gas H2, 2 grams per mole. 2 grams per mole. You understand? Molar mass of carbon, 12 grams per mole. 12 grams per mole. You understand that? Clear? So molar mass only we give, we have to put this unit. Yes? 12 grams per mole. 12 GMOL minus 1. Did you understand the lesson? Is the lesson clear? So how many topics you took here? We took RM already we learned. We combined it with mole. So mole. And then molar mass. And then Avogadro's constant. And there's a hidden story, number of particles. I told you. 1 mole if it contains this amount, 2 moles should contain double of that. 3 moles should contain 10 moles should contain 10 times of 100 moles should contain 100. Clear? So this is the 4 topics we are done. 4 topics we are done. Almost the lesson is done. That's it. We have to fill up the tube with the notes and we have to practice questions. That's it. Lesson theories are done. Theories are totally done. And we have to fill up with the formulas. 4 formulas are there. Formulas we have to take. Got the point? Okay. First, can you go to the writing book? Yes. We'll go to the writing book. I have given you short notes. Please take it on. Wait. Now you can see the difference here. This is this part. So I have given you for hydrogen element. Look at this, guys. Okay. I have given you this for hydrogen element, and this is for hydrogen gas. How it changes? This contains 6.02 into 10 to the power 23 H2 molecules. Correct? You understand that? This hydrogen, 1 gram contain hydrogen atoms. Avogadro's constant of hydrogen atoms. 2 grams because of H2. This contains 6.02 into 10 to the power 23, same number, but not atoms, it is molecules. It is molecules, H2 molecules. You understand that? Clear? H atoms, single ones, atoms, double, triple, combined ones, molecules. But the same number Avogadro we have to. Clear the point? We'll take the note quickly. We're gonna write from here. Okay. Go to your writing book. We can take the topic as moles and Avogadro's constant. Moles and Avogadro's constant.
So should we put like relative molecular mass or should we put like R?
Take the same note. RN. Same way. But write it in big letters, okay? Big terms, make it highlighted in one complete page. Avogadro.
So in the seminar, we'll be discussing all the chapters or the episodes.
After the class, I'll speak about this. This happens the entire day today, actually. This happens the entire day. And we are done with the lesson. We are going to fill up the notes. Avogadro's constant. But you know, every action has a reaction. Yes. 1 hour left. They said something. 1 hour or something. That 1 hour I will take later. I will come up. I will catch up that 1 hour that I spent here now, right? I will catch up somewhere. Right? Fine.
Not today.
No, not today. Not today. Not today. I don't know. You see. Avogadro's constant, shall I write? It is there on the tube?
No.
Okay. Yes, we'll write this down. Let's try it. The constant number of atoms, in an element or molecules in a compound, atoms in an element or molecules in a compound, when a mass of any substance equal to its relative atomic mass or relative molecular mass is taken in grams. But we learned earlier. What we summarized earlier, that is what the same thing. Can you see? Right? We said relative atomic mass taken in grams, relative molecular mass taken in grams. It is called 1 mole. And this 1 mole, how much particles they contain? What are the particles? Atoms in elements, molecules in compounds. This is what we term as Avogadro's constant. And how much is this Avogadro's constant value? 6.022 into 10 to the power 23 particles. 6.022 into 10 to the power 23 particles are there. Okay, and here there's a space, right? We write there here. Use a different color pen. Avogadro's constant. We are giving the symbol capital L, but it is a standard symbol. Sometimes in your schools you might not be using this. Anyone use this symbol already at school? No, right? Capital L. They don't, because that is not there in the textbook, so they don't use. This is a standard symbol L. Okay, so capital L, which is equal to 6.022 into 10 to the power 23 per mole. Per mole. In 1 mole, this is the mole. Okay. So the unit of Avogadro's constant is per mole. Per mole. Grams per mole comes for molar mass. Avogadro's constant comes for per mole. Amen. You sit there, sit there. You have any words? Yeah, we have to write this. Where are we? The side is no. Yeah, give it. You got a paper? You know something? Close by, we don't have a shop. Bookshop is not. Yes. So Avogadro's constant is equal to, take this, number of atoms or molecules dividing by number of moles. Avogadro's constant is equal to how many particles are there dividing by the moles. Dividing by the moles. So capital L is equal to capital N over simple n. Capital L Avogadro's constant, capital N number of particles, atoms in elements, molecules in compounds. What is capital N? How many atoms are there in elements? How many molecules are there in a compound? Divided by simple n is the number of moles. What is the moles? What is the moles? Right? Moles number, that is simple n. Right? So this is how we get the formula. Some questions are there where you want to find out this capital N. So capital N is equal to simple n into capital L. Simple n into capital L. Is that clear? So Avogadro's constant equal number of atoms over number of moles. Now this formula, don't remember in this way. I will give it in a different way. I mean subjecting capital N. That is easy. That is easy to remember. Fine. Accordingly, we learned about this, right? We learned about this, right? What is this? Any atoms, any substance, you take 1 mole, it contains Avogadro's constant of particles. 6.02 into about 23 atoms are there, correct? 24 grams of magnesium, 8 grams of argentum, 35.5 grams of chlorine, 1 gram of hydrogen, 12 grams of carbon contain the same amount of atoms in their relative element, right? So that is Avogadro. Same way, molecules you take, you can see all of them are molecular masses taken. All the molecular masses are containing the same number of molecules. Same number of molecules. Okay. So Avogadro's constant. So what is mole? Avogadro's constant equal number you are filling up for any. Okay. Hydrogen 6.023 23 hydrogen atoms you take. This is called mole. 6.02 into about 23 carbon atoms you take. This is called 1 mole of carbon. 18 grams of water contains 6.02 into about 23 water molecules, that is called 1 mole. 1 mole. So we write the mole is the amount of substance that contains as many basic building units as there are atoms in exactly 12 grams of carbon 612 isotope. Why we take carbon 612 isotope? Because carbon 612 isotopes 12 gram means that is 1 mole of carbon, right? Can you remember? 12 grams of carbon is 1 mole of carbon. In 12 grams of carbon, how many carbon atoms are there? 6.022 into about 23 carbon atoms are there. Equal to that value, if you take number of atoms in oxygen, hydrogen, nitrogen, any other atoms or molecules, that is equal to 1 mole. That is equal to 1 mole. That is the idea. Right. What is the formula here? This is one of the very important formula in chemistry. N equals simple M over capital M. N equals simple M over capital M. What is this? Moles equal given mass over molar mass. Mole equal given mass over molar mass. What is the given mass of the substance? You have to divide by its molar mass. You find out the moles then. You find out the moles then.
Moles.
Number of moles equal. Okay, amount of substance means number of moles. What is the given mass of the substance? You divide by the molar mass. That is a symbol.
Why?
That is a symbol. Why in the sense? That is a symbol that we are giving. Mass is already given the simple name. So for molar mass, again you can't give the simple name, right? We are giving the capital. That is the standard symbol we are using. Symbolizing that we need the symbol. Right. Now you see, these one we learned already. Check. Relative atomic mass of any element taken in grams, molecular mass of any compound taken in grams contain 1 mole. And how much atoms of molecules, how much particles 1 mole contains? Avogadro's constant 6.02 10 to the power 23. Repeat it. How much is it? Everyone? 6.022 in 10 to the power 23. How much is it? 6.022 in 10 to the power 23 atoms, molecules are there. Right? Fine. Please write that word 1 mole. And you have to fill it up, yeah? You have to fill up this. Yes. Right. Please write. Write this. I'll scroll it again. Have you done? What does it say? I told you we are rearranging the formula. Capital N number of particles equals moles into Avogadro's. You already learned this, but I told you 1 mole contains 6.022 into the power 23 means 2 moles contain 2 into that value. 3 moles contain 3 into that value. That value is L. 3 into L, 4 into L, 5 into L, 10 into L, 100 into L. That what we increase is moles. Mole into L, N into L, N into L. Simple in moles. 1 mole. How many moles are there? In 1 mole, how many are there? How much is 1 pen? How many pens you need? 1 pen, 100 rupees. You need 10 pens. 10 into 100, 1000 you have to give. That's the idea. Okay. How many units per unit price? How many units per unit price? How many moles? How much in 1 mole? You multiply total, you find. Total you find. Is that clear? Okay. So that is number of atoms. Number of atoms. Molar mass. The mass of a mole of any substance is called the molar mass. The mass of mole of any substance is called the molar mass. The mass of a mole of any substance is called molar mass. So molar mass of the substance equal mass of the substance dividing by number of moles. So the same formula earlier we reverse it or we subject it. Ultimately only 2 formulas are there. They are subjecting according to our requirement. Right. Now can you see what happened here? In the previous one we learned moles equal given mass over molar mass, right? Here you want to find molar mass. What do you do? Capital M you take here. Simple M over simple subject. Subject. Furthermore, I told you molar mass is equal to relative atomic mass equal to relative molecular mass equal to relative formula mass. Same particular, you get the total, that is equal. Okay, sodium chloride 35.5 plus 23, 58.5, 58.5 grams. 58.5 is the relative molecular mass of sodium chloride. What is the molar mass of sodium chloride? 58.5 grams per mole. Grams per. Water 18. Relative molecular mass is 18. What is the molar mass of water? 18 grams per mole. Calcium carbonate 100. RMM is 100. What is the molar mass? 100 grams per mole. That is all the difference with units and without units. Clear the point? So that is the end of the lessons theoretically. And we have to calculate. We didn't finish up. We have to go for calculations. Because the calculations are the major part where you will be strong. So step by step, we have to practice it. We have to practice it. Okay, fine. So some of the examples are there over. We'll take the question 1. Go to the right book. Find the masses of the following substances. Wait. Yeah. Find the mass of the Fleming substance. What is the formula? Look at this. Moles equal given mass or mole mass. This is the formula. Right? Guys, look here. Look here. What is the formula? Learn it right now. You have to memorize it right now. What is the formula? Number of moles equal given mass over molar mass. Repeat it. Number of moles equal given mass over molar mass. Repeat. Number of moles equal given mass over molar mass. Repeat. Now we will have to memorize. What is it? Number of moles equal given mass over molar mass. It's simple. Okay. Number of moles equal given mass over molar mass. Zaina, what is it? What is it? Huh? Am I there? No. Look here. What is it? Number of moles equal given mass over molar mass. Number of moles equal given mass over molar mass. Okay. Number of moles equal given mass over molar mass. N equals M over capital N. N equals M over capital N. M is given mass. Capital M is the molar mass. Now, whom I want to find? Find the masses. That means I have a subject. How do I subject? I have to subject this first. Simple M equals moles into molar mass. Am I correct? Moles into molar mass. That is how I have to do. Simple M is equal to N into capital M. Now, let me take the first question. Then let us do the question 1. Problem number 1. 5 moles of carbon. Now, how do I find? Mass equals moles into molar mass. For every question, you are give this. So, you will learn. For every question, you start from here. N equals simple M over capital M. So simple M is equal to N into capital M. You have to definitely write this because there is a standard formula. For every question, you have to write when you're writing answers. Now tell me how much is the moles? 5. How much is the moles? 5. Into what is the molar mass of carbon? 12. What is the molar mass of carbon? 12. 12 grams per mole. Why? Relative atomic mass I have to take with the grams per mole. So 12 grams per mole. That is there on your tube. The relative atomic mass table is there. Or relative molecular mass you can find. Adding them. Adding them you can find. 5 into 12 how much? 60. Mole to mole cut 60 grams. So how much grams are there in 5 moles of carbon? 60 grams are there. 60 grams are there. 1, it's 12. 2, 24. 3, 36. 4, 48. 5, 60. That's it. Yeah, just multiply to get it out. What about the second one? 2 moles of water. Again, moles equal given mass over molar mass. You want to find out this person, so you take it here. N into capital M. How many moles are there? 2 moles. 2 MOL into moles of water. H2O. Right? Moles of water I am writing here. Moles equal H2O, right? H2O means 2 into 1 plus 16, correct? Right? H2O, no? H2O. H2, 2 into 1 plus oxygen 60. It gives me 18 grams per mole. So that 18 grams per mole I am writing here. Correct? I'm just showing you how I got that liquid. So now 2 into 18, how much is it? 36 grams. Moles to moles, 36 grams. You understand that? Clear? Give me the answer in that way. The first 5. Still, did you understand? In first? Glucose C6 H12O6.
And if you have to add them, then to be add them on C6
Total we have to give. Hurry up. What is the answer? Ammonia 70. Third one 0.5 moles of carbon dioxide, right? Right here. Moles equal given mass over molar mass. Given mass moles into molar. How much is moles? 0.5. Molar mass of carbon dioxide. I am writing carbon dioxide here. Carbon 12 plus oxygen 2 into 16, correct? 44 grams per mole, correct? Multiplying by 44 grams per mole, half of that how much? 22 grams. Half of that how much? 22 grams, right? Clear? 22 grams, okay? What about the fourth one? 10 moles of glucose. Moles equal given mass over molar mass. You have to write definitely the formula. 10 moles and glucose how much? C6H12O6. It is 6 into 12. Carbon is 12 plus hydrogen 1. 12 into 1 plus oxygen 6. 6 into 16. Total it gives you 180 grams more. So you multiply 180, you get 1800 grams, correct? 1800 grams. What about 3 moles of ammonia? 3 moles of ammonia. Moles equal given mass over molar mass. Mass equal moles into molar. How many moles are there? 3. Into ammonia. Show that separately. Molar mass, nitrogen 14 plus 3 into hydrogen, 17 grams per mole. You get 51 grams, right? 51 grams. Did you understand that? Clear? Fine. So, next one, I have explained you the theory, but I will catch up with the calculations here. Yet, I want you to give a try at home because the formulas are given. A equals BC formula given means you can substitute and get the answers, right? Give a try to find out the answers for all up to 10. Up to 10. Okay, make it a must to give the maximum effort. Okay, give the maximum effort to get the answers and please do complete it. With the method, with the formula, with the steps, properly write them on the writing book. Not on the tute here, on your writing book you have. Is that clear? Right. Hold on.